Welcome to Physics World Online College, where simplified physics is presented to you for you to excel in your exams and learn it with ease. In our class for today, meant for SS1 and ST1 students, we shall be looking at the topic displacement. It's a follow-up on the last topic, distance. Here, we are going to learn about the meaning of displacement and its unit and how to calculate the displacement of a body. Please remember to subscribe if you have not done so, and also click on the notification bell so that you will be automatically reminded or notified whenever a new class video drops. Let's continue with our class. In our last class, we talked about distance and defined it as the distance of between 2 points is this measure of separation between the 2 points. And we said the unit of distance is what? Is meter, and distance is also a scalar quantity. That is, it has only magnitude, no direction. Now we will compare and contrast it with what? Displacement. Displacement is distance traveled in a specified direction. Because displacement has magnitude and direction, displacement is a vector quantity and not a scalar, unlike this distance as a scalar. So displacement is a vector quantity. However, displacement and distance has the same SI unit, which is what? Meter. So the SI unit of displacement is meter. Let's take note of that. Displacement is defined as the distance traveled in a specified direction. I said it is a vector quantity. What does that mean? That it has both magnitude and direction. The SI unit is the SI unit of displacement is meter. So if you are asked to differentiate between distance and displacement, what will you say? By definition, distance is a measure of separation between 2 points. Displacement is distance traveled in a specified direction. 2. Distance is a scalar quantity. Displacement is a vector quantity. I said, however, both of them have something in common, which is the SI unit. The SI unit of distance and displacement is meter. So because of that, going forward, you will see that distance and displacement most times are used interchangeably. However, they are technically not the same, which is what I just distinguished between distance and displacement. So for us to calculate the distance, the displacement of a body, let's take 2 examples, as we have example 1 and example 2. We have that in example 1, a body walked 500 meters due east. Remember, we have 4 cardinal directions, 4 cardinal points. We have the north, we have the east, we have the west, and we have the south. So we use this to tell direction. So if you are told that a body moves due east or eastwards, it means it's moving along this cardinal axis, due east. Likewise, if you are told that it moves what? Due west, it's moving along this cardinal point, this direction. If you are told it moves due north, it move upward. If you are moving due south this way, then if you say it moves northeast, northeast means somewhere here in between north and east. If it moves southwest, southwest. And take note, in this 4 cardinal axis or points, north, east, west, south, anytime you want to mention an angle, the angle you will state is always with the north pole or with the south pole. We use it to tell the direction. So we call it compass bearing. If I want to quote the angle here, it will be the angle with the north pole. If, for example, this is 30 degree, I will call it north, 30 degree east. Another way to say it, we can say 30 degree east of north. That's another way of telling direction. If you have an angle here, if I have this as 45, I will quote it as what? South, 45 degree west, at the southwest. And like I said, the angle must be with either the north or the south. So I can also call it 45 degree west of south. So it is good you know how to use this compass bearing to tell direction of points. Good. Now let's answer the question. A boy walked 500 meters to the east. Solution to example 1. A boy walked 500 meters to the east. So let's take that this is the starting point of the boy and he moved due east. I have to go this direction because this is north, this is the east. So due east means he moved this way. 500 meters. 500 meters is the distance, how far it has walked. Due east is the direction it has walked. So I went this way because what? He walked due east. It will not be wrong for you to take any direction other than what? East. Then we are told that it then turns back and walk due west a distance of 300 meters. Turning back, observe what I'm doing. He walk due west, so he's returning back due west 300 meters due west. Observe something. He walked just 300 meters. He did not complete the full length, so something is still left. So that is why they ask you for the what? The displacement from the starting point. So you will see that he moves 500 meters due east, then returns 300 meters due west. He did not complete the full distance. So what happened? You have a difference of 200 meters. That becomes the resultant displacement from the starting point, 200 meters. So how do you obtain that? You minus 500 meters minus what? 300 meters, giving us the resultant displacement. So I say that the resultant displacement from the starting point, the resultant displacement equals 500 minus 300, which gives us what? 200 meters. In what direction? In the east direction, because he did not complete the entire distance of the what? In the eastern direction. So this is 200 meters due east. Good. So once two vectors are moving in opposite direction, we say you subtract. That's another way to understand it. That the body moved first due east, in the positive direction and then move due west in the negative direction, you subtract 500 minus what? 300 to give you 200 will be the resultant displacement due east, or you say 200 meter from its what? Starting point as the resultant displacement. I said, or you can say the body moves 200 meter from its starting point. That gives you the displacement. Now in example 2, example 2 is more technical for us to solve. So solution to example 2, we are told that a student walked 30 meter due east. Like I said, due east means you move along the easterly direction, and then 40 meter due north. We are to find the resultant displacement in magnitude and direction. How do we answer that? Let's take that this is the starting point of the object. This is north, and this is east. This is the starting point. Let's call it O. So the student walked 30 meter due east. So 30 meter due east, I'll go here, 30 meter. This is the easterly direction. Now, this question, I can interpret it in two ways. How? Let me do this one first. I will say the body moves from this starting point due east and then 40 meter due north. So from here, we move north, 40 meter due north. So the resultant displacement will be from where it started to where it is now. That will give me the resultant displacement. Can you see that? I move 30 meter due east and 40 meter due north. The resultant displacement is now from the starting point to where it is now. That gives me the resultant displacement. And if you look at this now, you will see a right angle what? Triangle. In this case, I cannot subtract like I did here. Once I have a right angle triangle, for me to find the magnitude of this resultant vector, I will now have to use Pythagoras theorem to obtain it. I said there's another way we can draw this diagram. Let me just put that one here. So, but I will use only this one to solve the solution. Let me just show you. Now, how do I interpret that? If I didn't want to draw it, that the body moved 30 meter east and then 40 meter north, continuing its journey, and then find the resultant from the starting point. This is what I will do. If this is the beginning, and I'm told it moves what? 30 meter due east. I will go this way, 30 meter due east. I'm right. This is the starting point. And then 40 meter due north. I will come to this starting point and take it in the northerly direction. 40 meter due north. Do you see the difference? Now, for me to get the resultant, I will come to this starting point and take a line. This will be the resultant displacement. So for me to solve this one, I will still have to form a what? A triangle. So I will take a line that is parallel and equal to this, and that will give me the triangle here. So this line is parallel and equal to this line. So here will also be what? 40 meters. So you see that whatever I will obtain here is what I will still obtain here. So the issue is in the interpretation. Good and fine. So I'll continue to solve with this one. So I said for us to find the resultant in this case, because it's a right angle triangle, we're going to use Pythagoras theorem. So I say the magnitude of the resultant vector, resultant displacement equals, let's call it line ON, I'll square it, is equal to O line OE, I'll square it, plus line EN, I'll square it. So I'm using Pythagoras theorem to solve it because it's a right angle triangle. So this is giving me straight up, I have ON is square root of OE square, line OE square, plus line EN square. I will substitute the values now. So we have the displacement ON is equal to square root of OE. OE is 30, that's 30 square, and EN is what? 40, that's 40 square. 30 square will give me 900, and 40 square will give me 1600. So I have that the distance or the displacement ON is equal to square root of 900 plus 1600. That gives me ON is equals to square root of 2500. And the square root of 2500 will give me what? 50. So 50 meter. That is the magnitude of the what? Of the displacement. So here is 50 meter. So if I use this one, it will also be what? 50 meter, because it's still right angle triangle. I will still use Pythagoras theorem. Now, I have to specify the direction. So for me to specify the direction, I will look for the angle. I will look for the angle. Which angle? I will say, let this angle between this resultant displacement and the s-axis, I can call it alpha. If I call it alpha, I have to find angle alpha. I will now use SOHCAHTOA. So I say, let the angle, the resultant displacement mix with the s-axis, mix with the x-axis be alpha. So to obtain the angle alpha, I will use what? TOA. This side is opposite. The side facing the given angle is what? Opposite. While this side is what? Adjacent. So I will use, to obtain angle alpha, we use what? TOA. To obtain the angle alpha, we use tan alpha equals opposite over what? Adjacent. So that gives me tan alpha is equal to, my opposite in value is what? 40, and my adjacent is what? 30. Once you divide that, you will have tan alpha is 1.333. Now, to get alpha, you will take tan inverse. So we say alpha is equal to tan inverse of 1.333. So once you take tan inverse, that gives us what? It will give us 53.13 degree. Now, let me warn you here. Please, if you know you are going to take tan inverse or sine inverse or cos inverse of a value, you are advised to make sure that the value you are using is up to 3 or 4 decimal places, except in the situation where it gives you a sharp answer. Like if this were to be 1/2, I will get 0.5. I cannot get more than that. In that case, I will do tan inverse of 0.5. But if you divide two values and you are going to get numbers that are more than 2, 3, 4 decimal places, please don't use 1 decimal place. So here now, it will be wrong for a student to use 1.3. To do tan inverse of 1.3 here, your answer you get will be very far from the required answer. So you are warned. Once you know you will take sine inverse, cos inverse, tan inverse, after division, ensure your value you are going to take the tan inverse of is up to 3 or 4 decimal place. Please take note of that. Then we have got the angle with its x-axis alpha as this, but this is not the angle we quote. Like I explained to you, in compass bearing, the angle you quote must be the angle with the north pole or with the south pole, depending on where the object you are locating is. So here now, I'm not going to use this alpha to quote my direction. I'm going to look for the angle with the what? North pole. So if from here to here, I've obtained as 50 what? 3.1. This is a right angle triangle, it's 90. So to get this angle between the north pole and this resultant line, this will be 90 minus alpha. So that is what I will use to get my direction. So I will say the direction, the required direction is north. 90 minus alpha degree east. North 90 minus alpha degree east. So that will give us north 90 minus 53.13 degree east. That gives me north. If we do that subtraction, we are going to have 36.87 degree what? East. That becomes what? My direction. That is the angle between this north pole and this displacement. That is what you will quote as direction. I hope we get the point. So I will make the statement now. Therefore, that the resultant displacement is a magnitude 50 meter while in direction north, 36.87 degree east. I want to emphasize as well that although I have used this method by finding the angle between the resultant and the x-axis before I subtract it from 90 to get the angle with the what? North pole, a student can decide to use this triangle and find this angle directly. If you find this angle directly with the north pole, you would not need to subtract it from what? From 90. So you have to take note of that. So I'm making my concluding statement, that is, I say in conclusion, the resultant is 50 meter at, in conclusion, the resultant displacement is 50 meter at north, 36.87 degree east. So that is magnitude and direction. So you have to take note of that. Please, I have 2 questions as assignment for you to solve. You solve them and post it and send it to me. I will evaluate it and tell you if you are right or not. See you in the next class. Bye bye.